if we have two lines in the same plane, and we introduce a line that intersects both lines at two different points, what we've just introduced is what's called a transversal. We'll call this line L, this line M, and let's call this transversal T. When T intersects both of these lines, two groups of angles are formed. We'll label these angles with numbers. What we are going to be interested in is what is the relationship between these angles and what conditions need to be met in order for those relationships to hold. So, given that this unit deals with parallel and perpendicular lines, let's say we have two lines that run parallel to each other and are cut by a transversal. Assuming that we know L and M are parallel, we can start to recognize some relationships between these angle pairs once we assume that one thing has to be true. And that thing that has to be true is the corresponding angles postulate. Now you may have noticed that you've seen some theorems presented in class. Some of them we call postulate, some we call theorem. What's the difference? The postulate is an accepted truth that does not require a proof. So we need to accept the fact that corresponding angles are congruent when we have parallel lines in order to derive the relationship from all our other angle types. Now, before we get into the corresponding angles postulate and how it relates to other angle relationships, we need to be able to identify corresponding angles. Corresponding angles are angles that are in the same respective location in their groups. So we have this first group up here, and we have a second grouping down here. The angles that are in the same respective location we would consider corresponding. So for example, 2 and 6 are both in the top right of their group. 2 and 6 are corresponding. You could say 4 and 8, 1 and 5, or 3 and 7. The corresponding angles postulate tells us that corresponding angles are congruent, assuming the lines are parallel. So given the lines are parallel, the angles are congruent. Now, knowing that, let's see what we can come up with. I'm going to redraw this image. Black. Cool. So again, it's already established that the lines are parallel. We know that corresponding angles are congruent. So let's work with angle 2 and 6. What we also know is that if 2 is congruent to 6, I can also say that 2 should be congruent to 3 because those are vertical angles. And if 2 is congruent to 3 and 2 is congruent to 6, then I know that 3 is congruent to angle 6. Now, what's the relationship between 3 and 6? Those angles are called alternate interior angles. Therefore, we can come up with another theorem. We think that alternate interior angles are congruent, and they are. Theorems do require proof. and our proof is going to be based off of the corresponding angles postulate. So we accept that corresponding angles are congruent when lines are parallel. I use the fact that I also know vertical angles are congruent when lines intersect, and then through a transitive property, we can come up with the idea that alternate interior angles are congruent. Now, instead of well, we can still work off 3. Let's say we're looking at 2. We know 3 is congruent to 2, vertical angles again. And then we also know 3 and 7 are congruent because 3 and 7 are corresponding. Now, if 2 is congruent to 3 and 3 is congruent to 7, then 2 is congruent to 7. So we can say 2 is congruent to 7, knowing that 2 is congruent to 7. What types of angles are those? Those are alternate exterior. So we can come up with another theorem that we think alternate exterior angles are congruent, given the lines are parallel. And our reasoning for that, again, a theorem requires proof. Our proof is that 2 and 3 are congruent through vertical angles. 3 and 7 are congruent because of the postulate for corresponding angles. And then through transitive property, we can make a conclusion that 2 and 7 should be congruent. So given lines are parallel, now one more angle type to consider. What about the relationship between these angles on the inside, like 4 and 6? We can say that 2 and 4, these form a linear pair. And based on our linear pair theorem, we know that they're supplementary. And knowing that 2 and 6 are congruent, then I can say 4 and 6 must be supplementary through a substitution. So if I know that 2 plus 4 is equal to 180 because they are a linear pair, then I must also know that 4 and 6 equals 180 through a substitution because 2 is congruent to 6 because they are corresponding angles. So then we can make up another theorem that tells us that what we call same side interior angles are supplementary. But they're only supplementary given that the lines are parallel. So an important condition to recognize for all of these theorems and postulates is this fact here. Given the lines are parallel, we can only say these things are true if we know the lines are parallel. In a quick review of our angle types, 4 and 5 are alternate interior. So corresponding, we already discussed, are the angles in the same respective location in their groupings. Alternate interior are angles that are on opposite sides of the transversal, but on the interior of the two lines. So just keep in mind that the interior, and then you have the exterior, which would be the locations above and below. So when you see alternate, that's talking about on opposite sides of the transversals. Same side is referring to the same side of the transversal. When you see interior on the inside of the lines, exterior outside of the lines. So now that we know that these theorems are true, it must also be true that if we identify angle relationships, we can make a statement about the lines being parallel, and that's where the converse theorems come into play. So if it is also true that we've established that corresponding angles are congruent, that alternate angles are congruent, that alternate exterior angles are congruent, or that same side interior angles are supplementary, then we can say the lines must be parallel if that's true. So if any of those four things are true, you can say the lines are parallel. And what you're doing is you're taking the converse of that if-then statement that is established in the theorems and postulates to begin with. So a converse of a theorem is just flipping the if-then statement. The original was if the lines are parallel, then the angles are congruent. Or if the lines are parallel, then the angles are supplementary. So the converse would be flipping that if-then statement to say if the angles are congruent, then the lines are parallel. Or if the angles are supplementary, then the lines are parallel. And what converse theorem you use depends on what angle type you're dealing with in the problem. So that is an overview of lines and transversals and the angles that they form, the relationships they have, and how we can show lines are parallel with also understanding the angle relationships that are present.